Hi everyone, my name is Alvaro, and in this video I will show you how to use a minimal and maximum heap in Rust. So in order to use a minimal or a maximum heap, we need to use the binary heap, which is in the standard collections binary heap. So here at line 3 I'm creating my heap. By default, the binary heap is a maximum heap. So in the next lines, I'm adding numbers into this heap. So I'm adding the number 3, 5, and 1. For the maximum heap, or a priority queue, I will remove the 5 number, which is the biggest number in my heap. And then I will remove the number 3, and the last one is the number 1. Here I'm doing this, removing each number. So if I run this code, I will get this output 5, 3, and 1. To change this maximum heap into a minimum heap, I have to use the reverse type. So here I can add my reverse type. I need as well to reverse each number I'm adding into my heap. This reverse type reverses the comparison between these numbers. For example, if I have the number 1 is less than number 2, if I reversed each number, I will have the reversed 1 is greater than reversed 2. That's why this reverse gives us a minimum heap. So if I run this code, here I have 5, 3, and 1. Let's run the code. I have now 1, 3, and 5. This is a minimum heap in Rust. If I want to have only the number inside this reverse type, I can just type dot and 0, because the reverse type is a tuple. Now we have 1, 3, and 5. For my new situation, I would like to have a new type and use this my new type in this binary heap as a minimum or maximum heap. So I will create my new type, which is a tuple of I32 and I32. I would like to have the following situation. I just want to use the first number as a comparison. The second number would be just there to gather the first number. This type of structure can help us, for example, in a Dijkstra algorithm to find the minimum path between two nodes in a graph. Because here I can have the distance, and here in the second position a vertex related to this first position. So in order to use this new type in my binary heap to have a minimal or maximal heap, I need to implement the OR trait. So before that, I will show you this is actually a requirement. let's try to add some numbers here. New type. New type 3 and 0. 5 and 1 and 1 and 2. Here we have the trait OR is not implemented for new type, so we need to implement the OR trait. For implement the OR trait, I need to implement this comparison function, which compare between these two new type, self and other. As I mentioned before, I only want to use the first number in the tuple as a comparison. So let's do the following. Self.0, which is a i32 that implement CMP as well. So I will use this function. Now I have implemented the OR trait for new type. So to have this OR trait implemented for new type, I need as well to implement the EQ and partial word. This is a requirement for the OR trait. So let's do this. The partial word trait have the function partial comp. To implement this partial comp, I will do the following. Now I have the partial comp, partial comparison implemented for my new type. I need to implement the partial EQ as well. For the partial EQ trait, I need to implement this function, EQ, and I just have to return a Boolean type. So this is a self is equal other is equal other. I just need to do this. Self dot 0 is equal other dot 0. I have to implement only a EQ trait for my new type, but the EQ trait has no function, so I have only to do this. Now I can use a binary heap for my new type. Let's implement the debug trait here. Now I have a maximum heap of my new type. Let's check it out. Here I have 5, 3, and 1 as expected. So this is the maximum heap of my new type. If I want a minimum heap, I have two options to have this minimum heap. I can change the order here, and this another word, or just one, I don't remember. Now I have a minimum heap. Let's run our code. Now it's a minimum heap. Instead of do this modification, I can use the reverse type, because reverse type do exactly what we did here. It changed the comparison. So let's try use the reverse type here. Sorry, let's try here. Remembering, here I have, let's try, let's see. I return to my maximum heap, and now I'm gonna use the reverse type. Now I have a minimum heap, as you can see in the output. That's it. This is how we can use a maximum and minimum heap in Rust. In the next video, I'll show how to use this new type in a Dijkstra algorithm. Thank you for watching.